In this segment, we're going to continue talking about dividing fractions, and we're going to be using an improper fraction divided by an improper fraction, and we're going to be using the array or paper folding model to show that. And I'll be using 1 7/8 divided by 1 1/4 as our question. Now thinking about this logically, I'm dividing by a number greater than 1. So since I'm dividing by a number bigger than 1, I expect my answer to be less than my starting number, which is 1 7/8. So I need an answer smaller than 1 7/8. If I was dividing by 1 7/8, my answer would be 1. I'm dividing by a number smaller than 1 7/8. So I would expect my answer to be bigger than 1. So I'm looking for an answer bigger than 1, but smaller than 1 7/8. So my diagram might look something like this. I've got 1 7/8. So here's my 1 hole here, going across the top, left to right. I've got 1 and 1, 2, 3, 4, 5, 6, 7, 8. 7 of the 8, so 7/8. So I've got 1 7/8 shaded in. As I always start off, my first number I shade in downwards. And now this time, unlike the other ones where I've shaded in a portion of my vertical, I now actually have to extend it. I want to divide it by 1 whole, which is the distance from here down to here, but I also have to extend it to 1/4. So I've taken this piece and I've extended it. So I take a look, 1/4, 2/4, 3/4, 4/4. 1, 2, 3, 4/4. So I've extended it to 1 1/4 going downwards. So how many 1 1/4s, 1 1/4s can go into 1 7/8? The other way I can think of it is 1 7/8 can make up how many 1 1/4s? So I'm talking about 1 7/8, which is my yellows, can make up how many 1 1/4s? Well, I don't even have a full 1 1/4 yet. So I'm going to have to move some of these pieces down into this region in here. And that's going to cause my length from left to right across the top to get smaller. And that makes sense because I'm expecting an answer smaller than 1 7/8. So right now it's already 1 7/8. I'm expecting an answer to be smaller than 1 7/8 because I'm dividing by a number bigger than 1. And so my length from left to right has to get smaller. And as I move pieces down from here down into this zone here, then my length now is going to get shorter from here to here. And my answer is going to get smaller. And that kind of makes sense. So each one of these yellow bars here are 1/8 long, so they're 1/8 in this direction, and they're 1 whole going in this direction. This piece here is 1/4, which is 2/8 and 1 whole long. So I think I should be able to slide these pieces over, and I'm going to do that now. And so I've moved 2 pieces from here down to here, and my answer is getting shorter. But I still don't have full 1 1/4 pieces because I've got a gap down here. So we're going to have to somehow take this piece and fill it down into here. Now since I'm dividing by quarters, 1 1/4, and I've got 1, 2, 3, 4, if I just had 1 length pieces going down here, I would have cutting it into 4 or quarters. But I've got this extra piece is my problem. So what I'm going to do is I'm going to take this piece and I'm going to cut it into 4 separate sections. And then I'm going to move each of those sections down and to the bottom and fill those in. So I'm going to take this last remaining piece and cut up into 4. And I'm cutting it into 4 because I'm talking about fourths. So now I've divided this last 1/8 into 4 pieces, and I'm just going to slide them down into here so that I can fill up each of these sections. And so now I filled up my missing piece here. So now I have a full 1 1/4 piece down, all the way down through the whole piece. So I've taken my pieces from here and filled them down. So I'm asking how many 1 1/4s. I now have a full 1 1/4 all the way down from top to bottom. And so my question is, what is my length now across the top? Well, across the top I have 1 and 1, 2, 3, 4 eighths. So I could write it equals 1 and 4 eighths. And 1 and 4 eighths can be reduced to 1 and 1/2. So when we're working with dividing by an improper fraction, we're actually extending the height down, and so we have to bring pieces, instead of from the bottom up, we're bringing them from the top down, which makes sense because that's going to shorten my answer down. So we said our answer had to be less than 1 and 7/8, but it had to be greater than 1, and that's exactly what we ended up with our answer. Now, showing the technique where you change it to an improper fraction and then do our division is much, much faster. So here it is, 1 and 7/8. It takes 8 eighths to make 1 whole, plus my 7 gives me a total of 15 eighths. And it takes 4 fourths to make 1 whole, so 4 fourths plus the 1/4 I have is 5 quarters. And now 15 divided by 5 is 3, and 8 divided by 4 is 2. And so we get 3/2, which is 1 and 1/2. Much, much faster way of doing it. If I was a teacher, I'm not sure if I would spend a lot of time drawing the diagrams for a mixed number divided by a mixed number. I think I might do one that I know works out quite nicely, like the one I just did as an example. I want the students to understand that the length across from left to right is going to get smaller, just as we talked about dividing by a number bigger than 1 is going to get smaller. And so my answer is going to be smaller, and so it's going to have to move down. Cutting them up sometimes becomes problematic, especially since dividing by the mixed fraction, by the improper fraction, is so much faster to do. Now, normally we teach multiplying by the reciprocal, so I'm going to take a second and take the same question and work our way through that as well. And so we would say 15 divided by 8, or 15 eighths. Changed my division to a multiply by the reciprocal of 5 fourths, which now becomes 4 fifths. And I could get 60 over 40, which reduces to 3/2, which is 1 and 1/2. But we also want to talk about canceling. So we could end up showing something along like this line. 5 goes in there once. 5 goes in there 3 times. 4 goes in there once. 4 goes in there twice. And now I have 3 times 1 is 3, and 2 times 1 is 2. And again, I want to show where those numbers and where those cancelings come from. So we could show that 15 times 4 can be written 15 times 4. 8 times 5 could also be written as 5 times 8. 15 divided by 5 is 3. Whoops, sorry. And 4 eighths is the same thing as 1/2. So times 1/2, and I'm still going to get 3/2. And I can also show that the 15 over 5 could be written as these two numbers, 5 over 5 times 3/1. And so that 5 over 5 is the same as our magic 1. And so all I'm left with is my 3/1, which is where I said my 3 came from, which is also where this 3 comes from. There's my 3/1 there. My 4/8 can be written as 4/4 times, should be 1/2. So I can write my 4/8 times 4/4 times 1/2. My 4/4 is my magic 1, and all I'm left is 1/2, which is where my 1/2 is here, but it's also where my 1/2 is when I show my cancelling up here, my 4 and my 8. So now I see that I have 3/1 times 1/2, and again I get my 3/2 answer again. So in this diagram, or in this example, this segment, I've done a mixed fraction divided by a mixed fraction. I've got my answer, which is smaller than what I started with because I'm dividing by a number larger than 1. I've shown how it can work with the multiplying by the reciprocal. I've shown how the cancelling works in multiple ways. I've shown how dividing by an improper fraction also works. So we have lots of techniques to show how to do an improper fraction divided by an improper fraction, or a mixed fraction divided by a mixed fraction. And I'm not sure if I would spend a lot of time showing the diagram, as long as the student could explain what kind of things they can expect to see happening, being that my answer is going to be smaller than what I started with because I have to fill down in my diagram.